you guys got to skip. Did you get to skip 71? Was that right? I think you went from 51 to 79. And there were some other ones that I canceled out too. But anyway, yeah, so ignore 71. But even then, you have no evens because I let you have all odds to check and come today with questions. Let me get back real quick in case some of you were still writing down that review. And let me open up your book. It's always scary when you hear a phrase like, she believed me. I'm like, so you were lying? Anyway, so we're going to chapter 6, section 5. It's okay, that's all I heard. I don't know any more of the story. I was just like, I don't like that phrase. But I have no idea what you're talking about, so I don't know. Here we go. I have the book open to 6.5. Do you guys have anything that you want to talk about? Homework last night that was due today. Not the review yet, but 6.5. Yeah, Griffin. Perfect. 79, we'll go look at it. Anything else besides 79? Sweet. So number 79, I'll take a last call just in case Aiden wasn't speaking for the whole class. But, thank you, Aiden. 79. Could have been a beast. 79 could have been a beast. Because 79 says that I'm supposed to raise a binomial to a fourth power. Now, we haven't even done Precalc triangle or sequences in series this year. There's a thing called Precalc triangle. That allows us to do some binomial multiplication a bit quicker, a bit faster. Precalc triangle says anything to the. Maybe I'm kind of cheating a little bit, but I think at least some of you remember Precalc triangle from last year. No? What it ultimately helps us with is if we have to raise a binomial to a fourth power. I could use this to help me raise this to the fourth power. Why? Because technically this means 3. Can I just use that cis notation to be lazy? Cosine theta plus I sine theta. 3 cis 15 times 3 cis 15 times 3 cis 15 times 3 cis times 15. I have 3 times 3 times 3 times 3. Oh, that's why we raise 3 to the fourth power. Because you're going to have 3 written 4 times. But then you have this guy written 4 times. I'd have to FOIL. And then I'd have to multiply again. And I have to multiply again. Or I could use this weird trick with 14641. That still takes a lot of work. It's called binomial theorem. Or, well, then I'd also have I squareds and I cubes and I to the fourth that I have to think about what that is. Or, there's a really nice formula. And the really nice formula says, if I'm raising a complex number to a whole power, to anything bigger than 1, so not like a cubed root or a squared root or anything like that, which is why we skipped it. But anything to like the second or the third or the fourth, all I have to do to the angle is say, after all that fourth power junk and all kinds of t-proof trig identities, simplifying I squared, we're going to end up with, you guys shouldn't have shown much work, because what was the only thing you really had to do? How does the formula go? R cis theta raised to the n power is r to the nth, got it, times cosine of n times the angle, so just 4 times 15. And you don't have to do any more work than that. We can forget about our Precalc triangle, we can forget about raising a binomial to the fourth power, we can forget about I squares and cubes and fourths, and we can forget about cosine squares and sine squares and lots of trig identities. And we can say, oh, it's just 60. Now, Griffin, I actually don't know what the directions are. Were you allowed to, or were you supposed to stay in what we call trig form, or did it say to keep going to standard form?
I have to check.
Can someone help me out? Standard. So if we were supposed to go to standard form right now, this is what we call trig form. Standard form would say, well, hopefully even in trig form, 3 to the 4th is 81. We have to actually take that 81 and actually get those numeric coefficients to find our a plus b I. But the nice thing is, technically these are unit circle. 60 degrees is 3, 2, 1. 1/2 for cosine. Square root of 3 over 2 for sine. And all I need to do is just multiply that by 81, which ends up being 81 over 2. Did they do a decimal? Oh, they did. Okay, so 40.5. Which was 81 over 2, and then 40.5, which is 81 over 2, square root of 3. Times that. Yep, yep. These are two different ways of writing the same thing. Trig form versus standard. Is that good? Yeah. Last call questions? 6-5. Oh, yeah, with the weird angle, right? Number 19 was one of those where tangent inverse of b over a was not enough because, first of all, the directions. Did it say something about, were you doing trig form? Trig form, okay. Because I'm going to use words like, hey, direction and magnitude. Why am I using words like direction and magnitude if we're not doing vectors? You can think of it, yeah, you can think of it like a vector, sort of, because of the graph. And so the graph technically throws us in the second quadrant going -7, +4. My r is like my magnitude. My direction is my theta. So when I'm trying to get it into my trig form, which, yeah, you should definitely put trig form of complex number on your formula card, right? That's right, there are cards at the front. You need the formula card. I don't know if we're going to have a copy, but there are more cups on the side. Yes, there's a full sleeve one. But coming back up here. We can find r the same way we would have found magnitude of vectors. And so then we get to use our square root of a squared plus b squared, which ends up being 49 and 16 is 64? No, it's not that nice. There's no way. 65, thank you. Which has like a 5 and a 13, no perfect squares. Alright, whatever. We're stuck. But we still need an angle. What's the formula that with vectors and also with complex numbers I say you should use to find the direction? Okay. Tangent inverse of b over a, which would be the same thing as in this case 4 over -7. The struggle is when I go looking, I put a colon, not an equals, because I'm using the word use tangent inverse, not equals. When I plug in b over a, my calculator gives me help out. Is it in radians or is it in degrees? Those of you that have already traveled this path and figured it out. Radians or degrees for this one? Ooh, okay. So since it's in radians, that makes it even a little bit messier to know what's going on, because in radian mode, good for calculus, hard for visualizing. We get something awkward. You stare at that and we're like, But if you remember what I said yesterday, well, or even what we learned before about inverse trig needing to be invertible, passing the 1-to-1 test. My calculator only looks in these two quadrants. And guys, if it's a negative number, where must it be looking? Quadrant 4. So wherever this is. Which if we drew our picture, we're like, oh, as long as I've done it right, it's symmetric. It has the same reference angle, just in the wrong quadrant. So I don't even necessarily need to go to degree mode and visualize that it's -30-ish. I'm making that up, maybe it's 20-ish. I can actually just know you're in the wrong spot, buddy. So if you're going down here, all I need to do is, Vanessa, you already said the key to the answer. Add pi to get to the other quadrant. So I'm able to say, okay, that's the 4th quadrant angle. I need to get around to the 2nd quadrant. In order to do that, I need to add pi for my theta. And so adding literally pi, which is, I think, second caret, the second caret button, can also be plus 3.1415926. You end up with 2.622, which is what I could throw in my trig form of a complex number expression of that. Okay, I know some of you guys have already worked on your review, at least some. Now is not the time necessarily for us to go over questions, but it will be soon. So except the book doesn't like the review either. That's okay, I have a book. I'll get the webcam up. I will be available in just a little bit after I go over hints on the test. Ooh, some of you want to open up your notes or you want to open up your test review. Where do you write down the hints that I give on the topics covered on a test? And you might want to make a little separate category for formula card because I am going to give you some specific hints as to what I would include on my formula card if I were you. But also to say that I am getting ready to cover any review questions you guys have if you do end up having them after the hints on the test. So, hints on the test, yeah. We sadly have a student who has not yet made it up, but they're going to really try to come in today. So, it's kind of been chilling and waiting. The nice thing is I think if they make it up today, you guys can take your test tomorrow, and then I will give it to you. You still have a week to do corrections, but I'll have it ready for you when you finish your test that you could be playing with corrections or starting homework on that tomorrow. But yeah, you guys definitely want points back on that. And the nice thing is it's the first test of the semester, which meant that test had half points back. And this one's still good. It's going to have a third points back. Oh, we haven't taken this one yet. You're only missing chapter 5. And you guys got the 5.1, 5.2 quiz back. Like you got that one back. Oh, yes, it's chilling right here waiting for you. Anybody else absent? Sadie, you were absent too. This was back. So the quizzes, but the test, yeah. We're getting that last made up today. There's been weird stuff. People were on Thursday, on Friday. People were sick. It was a little bit of a struggle. All right, guys. Those formulas you do not get to have on your card, right? So if I were you, I'd take a picture of them and I'd make sure I know how to use them and have them memorized. Now pause. Even though they don't get to be on your card, as soon as you get your test, what are you always allowed to do? Write anything down. Remember the unit circle? Remember your cheater chart? So if you want to just like practice writing those and then as soon as you get your test, just write them out, not a bad idea. It's that you don't have to like remember them in the midst of a problem that you're already kind of overwhelmed by the test. Does that make sense? Strategies. Just strategies. But those are the formulas that are not allowed to be on your card. So when I walk around, as soon as I pass out the test and look at your formula cards, I mean, it doesn't matter if you're like, oh, I just wrote them down. No. Keep your formula card completely devoid of any of those, because if when I walk around I see any of those, it gets ripped up and thrown away. Well, a little more gracious than that. I'll probably just rip out the part that it's on, but when I rip it out, I might rip out other stuff. Not on purpose, but some people write it on both sides, and when I rip out their law of cosines, they just miss all their vector stuff on the back. You're allowed to use both sides. You're allowed to use up to a half sheet of paper. You can use a card, a big card. You can use a half sheet. Whatever you need. I let you have space on this one. Good? So what are you allowed to write? Anything else? Besides specific examples with numbers, because I don't want you putting a homework problem in and assuming it's going to be the exact same when it would have been better to have a general formula, because some of the things might change when it gets to an example on the test. If you want to hear my logic as to why those specific examples, but can you draw pictures for specific examples, with triangles for specific examples, with variables and what you did with them? Yes, and yes. Just not specific, like, oh, well, the answer was 37.624. None of that. But anything else, pictures, diagrams, etc. We'll talk about that more. But anyway, you're allowed to use your calculator on the entire thing. But the test does start with 6.1, 6.2 stuff. In the multiple choice, I normally try to go in order from sections, which is similar to your test review in your book. So you're going to start off with law of sines or law of cosines. You get to choose, but based on the information, if you have mostly sides, what formulas you have mostly angles. If you ever need to get to an angle with law of sines, you're going to have to use a sine inverse, and it might be ambiguous. If you ever have to get to an angle with law of cosines, you're going to have to use a cosine inverse, but at least you get straight to the answer. If you've plugged into the formula perfectly and your calculator says error, could it be an impossible triangle? You're also going to have a couple different areas. And guys, based on the areas, once again, if you're given all sides, please use Heron's formula. It's the bottom one with the S, but you have to know who S is to use it. But if you have a couple sides with an included angle, you can use the other one. Now, guys, up on the board, hold on. Whoa. Weren't there like 3 different variations of that SAS area? And weren't there like 6 different law of cosines? And weren't there like 2 different? I've given you the main idea. Do you know how to use the main idea? Meaning, do you know that this one, I can use BCA, or I can use ABC, or I can use ACB. It's any side angle side. They all work. Same thing here. I can use this with angle A and side A, and these are the other guys, or I can use this with angle B and side B, and these are the other guys, or I can use this with angle C and side C, these are the other guys. It depends on your brain. Are you able to have a general, like, single formula and know how to do all the rest, or do you need to memorize more? I don't know. That's a good question. If you want to come talk to me, we can process through it. Okay, then we get to vectors. I went looking just a second ago in case, unless someone borrowed all mine. See anything? Over on the left side? Yeah, there you go. Okay, then we get to vectors. Guys, vectors can be as easy as doing vector operations to components. How nice was it if you had an AB and an AB, like adding or subtracting or multiplying? So easy. Well, multiplying you need to know the dot product formula. But yeah, it's in components, like, got that, right? What if it's in I's and J's? Do you know how to deal with them? Adding, subtracting, putting them in components, hopefully, right? It's pretty logical if you've understood them all along the way. Although components did get tricky, if I give you an initial point and a terminal point, you have to subtract the right direction. So how does that go again? Do you remember? If I give you 2 points, how do you find the components? Which one subtracts the other? Yeah, the terminal or the ending one minus the initial one. So it could be like Q minus P with the X's and the Y's. That might be something for you to look up. Like, what if I'm given 2 points? Do I know how to do components? Unit vectors, ooh, there's a way to do that. But then components, what if you have them, but you need magnitudes and directions? Oh, there are angles for that. There are formulas for that, and we just practiced them with Vanessa's question in number 19 with complex numbers, ironically. Dot products, angles between. Wasn't there a formula for that? That used the dot product? More dot products. Oh my goodness. Complex numbers, do you know how to put them in a graph and find their absolute value? Do you know how to go from trig form to standard form? Do you know how to multiply or divide or raise to a power a complex number? And that's the entire multiple choice. Sounds pretty basic in the multiple choice section, as long as you have the formulas down that you need in the sections that you can. And as long as you have the formulas down in your mind, or even like you get to a point where you can throw them down in your test really quickly and know how to use them from the earlier sections. But you guys should probably be most concerned with, besides making a good formula card and making sure you have all the topics I just said, the long answer. So, long answer, there are 3 with 1 bonus. There are 3 with 1 bonus. One of them is just, I give you 3 pieces of information of a triangle and I tell you to solve for the rest of the triangle. Very 6-1, 6-2, and you get to choose how to solve. You could start law of cosines and then go law of sines. You could start law of sines and then go law of cosines. Does that ever happen? I don't think so. Anyway, you can solve using whatever you need as far as law of cosines or law of sines. I give you 3 pieces of information. It could be 2 sides and an angle, or 2 angles and a side, or 3 sides. I give you 3 pieces of information. You solve for the triangle. It will be possible. both somewhat from vectors, from 6-3, 6-4. One is from 6-3, one is from 6-4. I can tell you this one. One of them, you're finding the sum of vectors, which can also, then we know the snazzy term. Do you remember the snazzy term of the sum of vectors? It's also known as the, starts with an R. The resultant. It could be the sum or the resultant, like the overall result. The sum or the resultant. We did multiple problems like that. It's not like the hardest, aka it's not the system of equations with the cranes or with the two tensions with x's and y's. It's not the hardest. But I haven't given you components either. But it would be easier if you found the components. Oh man, too many hints. I'm done. Anyway, sum / resultant. You don't have components, but it sure would be easier if you found the components. The formula you said 5 times that day when I asked you. And then the last one has something to do with, I already told you this one, work. Work along a horizontal. Not a crazy dot product one, but instead you could basically use a right triangle. We put the formula in our notes and circled it in the yellow one. Is someone driving? Are they pushing? Are they pulling? Doesn't really say. There's a rope involved. Anyway, and then the last one, the bonus, is one of the 3 types of word problems we did from section 6.3 that needs a picture. And oh, that should be a hint in and of itself. It's one of the 3 examples that we did from section 6.3. It's like that. And it's the one that needs a picture. And there's not a lot of space to solve. And because you don't need it. If you have the picture, you're golden. If you don't, oh well. All right, cool kids. With that, we have our test tomorrow. Make sure you have your calculator, please. Everyone right now, put your calculators in degree mode for the entire review. The only time you might ever want to go to radians is if you're doing section 6.5, but I'm pretty sure the ones I just told you from section 6.5 don't really need a calculator. The only time you would go to radian mode. And I'll remind you again tomorrow, like, make sure you're in degree mode, because that's what you should be in for the majority of the test. Basically all of it, except maybe one 6.5 one. If you guys want right now to get a formula card, if you want to like split a half sheet with someone and start working on that, to be honest, I think that's your best resource for tomorrow besides the review and memorizing those formulas. Questions? Emma?
Can you do number 15? Because I keep telling
15 is 1. Yeah. Can you keep getting something weird?
Yeah.
Let me get that set up. Nikki, do you have a question too? Never mind. If you do, let me know. Diego. Yeah. Kiddos, I don't mind if you move around the room now. I don't mind if you do whatever is most helpful for you for tomorrow, which some of you, to be honest, is just writing as many notes as you can because your notes are behind, or updating your table of contents. But for most of you, it's making a formula card, it's working on problems, it's asking advice from your classmates. But I'm not going to babysit you. Be productive. Don't be going crazy. I'm just asking for people to be able to hear when I go over homework questions or review questions. But besides that, I'm good. So 15 and 17, right, Emma and Diego? Okay. And 15 is an area problem. 17 is a word problem. Got it. Emma, I see in number 15 that we should probably be using this formula, right? Okay. You said things don't seem to be working out. My first question is, are you in degree mode? Yes. Cool. Thanks for having that. So then, the nice thing is, if it helps your brain, you can totally, just to the class at large, because I'm pretty sure you've already set it up. Drawing a picture helps us just kind of see that, like, oh, hey, that's right. Little a is across from big A. And then we have our side angle side, which is exactly what I need for that area formula. So then if you're plugging and chugging, it should be as easy as a bring in sine, not cosine.
Oh, it's not.
There you go.
Okay.
So careful. Actually, no area uses cosines, if that helps.
Okay.
Because then Huron's just uses a semi-perimeter. But yeah, that got it. Nikki?
Number 9, I
Let me come back to you as soon as I cover Diego 17. That was number 9. Cool. So Diego, what's going on? From a certain distance, so I see somebody far away like on the ground. An angle of elevation to the top of the building is 17 degrees. At a point 50 meters closer. The bummer of this is that you only have a clue about the outside of 2 triangles, not the inside, which makes it tricky. I know the angle of elevation is 31 degrees. So as I move closer to the building, I have to look up higher to get to the top is kind of the idea that's going on. And we're supposed to be figuring out what this guy is. The nice thing is both triangles, the spread out one and the closer one, both use an opposite side of x. And they gave me a clue about adjacent, even though I don't know what it is. So here's what I'm going to do. I have 2 unknowns. I need 2 equations, but I have 2 triangles. I'm going to use tangent because I'm seeing opposites and adjacents with my angles. So I'm just going to set up and say, all right, well, this doesn't seem to have any bearing. They don't tell me any clues about it. So let's forget sines, cosines. Let's forget hypotenuses. Pythagorean theorem, once again, it's not going to help. I'm just going to have a z. 2 triangles, 2 unknowns. Tangent says, tangent of 17 is opposite over 50 plus 1. There you go. And then tangent of 31. The way it's written is gross. But if I do a quick little, maybe it won't be a quick little. The nice thing is I wouldn't think elimination, but I would think of at least I've gotten the x alone. So now I know, well, these x's are the same. These expressions have to be the same. All of a sudden, my life is a little bit easier because now I have 50. I can multiply. That's really just a number. It's just a decimal in my calculator. Depends on how much you want to go straight to the answer with one plug-in or how much you want it to make sense. In the ones with the cranes, we could, or we did, or some people should have just gotten a decimal, gotten a decimal, gotten a decimal. It's easier for your brain to process. But for me, trying to make it as precise as possible, I'd say like, hey, I have 2 different y terms. I'm going to subtract my y term, factor out the y, and then divide. I would actually end up with y is equal to tan of 31 minus tan of 17 being divided on the other side. So there is a way to go straight to the final answer. But that's exactly what you would have gotten. Just maybe you would have had to hold on to a few decimals along the way to make it as precise. You could have also just said, hey, it's a number y, I'll combine my y terms, divide. It's the same thing. Just I'm lazy and I'd rather put it in this. Is that good? Then once you have y, you're actually trying to find the height of the building, but just throw it back in either of the other ones. Yes, ma'am. Number 9. Let me give Diego a second just to process and down whatever he needs. Anybody else? 17 is a bit tricky. 17 is a bit tricky. You might want to at least grab a picture of the scenario of what's going on and that I'm using tangents. Not because, to be honest, from the hints I gave you on the test, I'm not sure there's anything tomorrow where you need a system of equations. I haven't made the math to get into the solutions that difficult. So not that you necessarily need to memorize this for tomorrow, just that it's a good physics problem that you have the ability to solve from what we've done this chapter, so I thought it was a good one to throw in. Anyway, anyone else that wants it, it's going to be disappearing in 5, 4, 3, 2, 1. It's on the YouTube video if you guys need it, or it will be, I should say. Number 9. Sounds an awful lot like one of those long answers on your test where you're given 3 pieces of information, and Nikki, I think we're just supposed to solve, yeah?
Yeah, but I tried it a few different ways and got some of the answers
coming as soon as my computer decides to wake up. Come on. Oh, there he is. Double check real quick. You're in degree mode, yeah?
Yeah.
Okay. You're using law of cosines? Okay. I only see one angle, so I would naturally just do law of cosines. Were you aiming for...
No, I was going to use law of cosines, but it says to use law of sines specifically.
Oh, actually, I just realized it was B with B. Yeah, law of cosines would be nasty because you would be missing an A squared. Yeah, you'd have the B squared filled in, and you'd have the cosine B, but you'd have a quadratic formula. Don't use law of cosines. If that was an A, use law of cosines. Okay, so law of sines. I'm missing C. Yeah. I think I brought this up a second ago when I was giving hints whenever you're solving for angles without just being able to use 180 minus, because you know the other two. You're always going to be having to use an inverse trig. This one's inverse sine with law of cosines in a different situation and be inverse cosine. The struggle is you technically, this is the ambiguous case. Whenever you use sine inverse, not cosine inverse, he's good. He goes straight to the right answer. Sine inverse, we technically need to check both. It's ambiguous. It could have one or none or two solutions. So we're just keeping our options open, saying, I don't know, I'll see. Now, when you're plugging this in, I'm going to do it up here on the screen so you can see me do it, Nikki. Are you using that fraction feature I showed you?
Yeah.
Okay. No, that's a good thing, because if you're using the other, it's very easy to get things a little messed up. Or to end your, to accidentally end your sine inverse a little early or something like that. So if you're using the fraction feature, oh, I guess I did it twice. Okay. Let me double check my mode, because I'm not sure I'm in degree. Oh, I am. When you use that fraction feature, you'll be able to do a single sine inverse of alpha y equals enter. It was a lifesaver. Unless you want a decimal that gives you a fraction, then kind of not. But we have our 10, we have our sine of 150, and we're dividing it by our 30, and then we're ending that whole shabam. But we can also do 180 minus that whole mess, just to consider whether or not there might be more than one. So what I'm seeing is a very tiny triangle. I have B being like a super obtuse angle, because 150 is like almost 180. It actually should be even more. And I have, let's see, that's A, that's B, that's C. C is 10. Oh, C is tiny. B is 30. Right away when I saw 9 point something versus 170 point something, 170 is a no way, because I can't have 170 and 150 in the same triangle, so I don't even have to worry about the ambiguous case, because those two, they can't coexist in a triangle. This 9-degree thing, I mean, he can. There's just not a lot of room left, but I guess the 150 was kind of taking up most of the 180 to begin with, so I don't have to worry about the ambiguous case. I can ignore this 172, but I do need to think about my third angle by doing 180 minus my 150. And then minus to see how many degrees are left. But Nikki, it is a weird situation just because that 150 is a very, 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 very flat triangle. So you're going to have some weird angles that don't have much measure on the other side. And so in this case, I think if it's matching up, I'm seeing 9.594 and 20.406 as my other two angles. So the first one that I found was angle C. And then the next one was my angle A. And I was too focused on the letters and not on the actual 20 point. But you're still missing one side, yeah? What was your logic as to, or what method were you wanting to use for the other side, which is A? You have options. You can do law of cosines or sines. Okay. So in law of sines, we could go ahead and just set up our little A as our missing dude. Bless you. Sine of A, I'll just plug in the big old long one. And I have my, what do we know? Oh, we know 30. And sine of 150. So I would just multiply my sine of A that I have in my calculator over there. And I should be good to go. You could use that nifty fraction thing, or in this one it's just multiplication and division with no extra craziness, so we could have just done that too. But we have our 30 sine of, go Selim. A is a 22? Yeah. Oh, that's not helpful. Oh, did not let you steal it? 30 sine of, oh, there we go. All over sine of the other dude, which is 150, yeah. How's 20.92 look? It's 90 though. Fancy on the test, guys, for the multiple choice. You're just making it match. So you don't have to worry about tenths or hundredths or thousands. Just do what the multiple choice answer would do. And for the long answer, for me, just remember, don't round into the end. Don't round until the end. So hence you see me in the calculator scrolling up and stealing answers with more decimals, etc., etc., etc. Because that's what we need to be able to use. Was there anything else you guys wanted to see? Any other places that you're still? Or formula correct questions about good things to put on there? I gave you hints about like an angle between section 6.4. No projection. Don't worry about projection. Because the work will be easier. Alright, let me know if you need me. Otherwise, I'm going to pause the video. You guys have about 10 minutes, a little bit less, to keep working on whatever you need to work on. Remember, if you want to grab a formula card before you leave, totally cool. Bummer is today after school, there is a last accreditation Baba North Campus that most, if not all, of the teachers are going to. Maybe not all, but most. Kind of a big deal. So I will be taking off pretty close to 2:45. But I'm here every lunchtime. I'm here 7 period. So if you guys need me, make one of those work. And if not, you can always pop in here tomorrow. Tomorrow's Thursday. I don't have a teachers meeting. Teachers have a professional development prep on Thursday mornings. You can pop in, show me your formula card, give any last minute tips or tricks or tweaks if that would help. Is that cool? Alright. I'm done. You guys can talk, you guys can collaborate, you guys can multitask. Hopefully.